Let us have more problems on current electricity. Let us understand the list of formulae, the standard formulae. Then we go for the problems. The first formula is I equals N into E into A into Vd, where I stands for current strength, that is current carrying in a conductor, and N the number density of free electrons, and E electron charge of each electron. A stands for area of cross section of the conductor, and Vd drift velocity of the electrons. And equation 2, this is a relationship. Equation says relationship among the different parameters. And second equation, V equals E minus IR. This V stands for potential difference or potential across the external circuit. External circuit having the cell, external circuit having the cell whose EMF is E and the internal resistance is R. I stand for current in the circuit. And you can write this equation as IR, because IR means external resistance in the external circuit, and current in the circuit remains same. Whether current in the circuit or current through the cell, I remains same. So if you replace V is equal to IR and write this equation as I equals to left hand side, take I as a log factor and write this as I equals E by R plus R. So E equals cell EMF or external resistance, this small or internal resistance I is the current in that circuit. And this equation is for if there are two cells, you know, they can be connected either in series or in parallel. If they are connected in series, the effective the effective EMF of the cell is E1 plus E2. That is a E of one cell, E of other cell. And effective internal resistance. Effective means it is a resultant value for the series connection. It is R1 plus R2. They are the internal resistance of the two cells. The same cells are connected in parallel. We have this equation, that is effective value. It is even R2 plus E2, R1 plus R2. These are the EMF and the internal resistances. And this is effective internal resistance is R1 into R2 divided by R1 plus R2. Remember these equations while solving the problems. First problem is, I have put the data. I have not put the problem, I have put only the data of the problem. I will read the problem. The problem is, the conductor carrying a current, that is 2 amps. Current carrying in a conductor is 2 amps. The conductor has a cross section, area of cross section, this value, and that conductor has the free electron density, that is electron density of free electron is this value in SI per meter cube, in SI square meter. Calculate this was drift velocity of the conductor and current density of the conductor. J stands for current density. This equation is applicable. So in this equation, all these are given except Vd. So we can write Vd equals, that is I divided by, substitute the values. Value of I is 2 amps, 2, N value is given and E value is known. That is 1.6 into 10 to the power of minus 19 joules. That is 10 to the power of minus 19 coulomb. That is area of cross section. Simplify, we get this value 0.1041 meter per second. That is a drift velocity in the conductor. And current density in the conductor is, definition for current density is ratio of the current to area of cross section. Both of them are given. Current strength and area of cross section. So write them and simplify, you get this value, that is 1.33 into 10 to the power 6 amperes per square meter. It is the current density in that conductor. So this is how it is solved. Let us move on to the next problem. Here also I put only the data. I will read the problem. According to data, I put this diagram. The problem is, there are two cells and EMF and their internal resistances are mentioned. These are the values, these two cells. And these two cells are connected in parallel in such a way that current from both of them flows in the same direction like this. That is the problem. They are connected in such a way that current from them flows in the same direction. And this connectivity, what is our parallel connection, is connected to an external circuit having resistance 10 ohm, and ask you to calculate what is the potential difference across this resistance, or what is the potential drop at this resistance. That is the one we need to calculate. So this is R, this is V, this is I. What is I? So this I and this I join here together with the total I. So I equals I1 plus I2. So look at this, according to the Ohm's law, V equals IR. V is supposed to calculate. So R value is known, but I value is not known. I value is not known. How do you calculate value of I in this circuit? Recall this. I said when there is a cell and resistance external and internal, E divided by R plus R. Since the circuit is not only one cell, there are two cells. Therefore, there should be effective E and effective resistance. This is I for this. This is the value of I for this circuit. We know this equation for this, equation for this. Calculate them and put them into equation. For calculation, use this equation. Since the equation is for parallel connection, this equation for parallel connections. Write these values. All these values are given. This one E1 and R2. 2 into 2. 4 into 1. 1 plus 2. Simplify 8 by 3 volt. So 8 by 3 volt is the effective EMF of this parallel connection. What is effective internal resistance resultant of this equation? Given the values, substitute them and simplify 2 by 3 ohm. That is RE, this is EE. Put them into this equation and simplify. Let us see what we get. So I equals, this is EE divided by RE, and 10 value, R value is given, external resistance. Simplify 8 by 32, 1 by 4 amp. So 1 by 4, what is value of I? 1 by 4 amp. So put this value into this value, given value into this, calculate V is equal to 2.5. What is 2.5? 2.5 is the voltage across this or voltage drop at this resistance. This is the one we have that is solved. And the next problem is, I read the problem is not yet. Here there are two cells, those two cells are identical cells, that is these two cells are the identical cells. What is meant by identical cells? Identical cells means their EMFs are same. This is the EMF EMF equals C. Their internal resistances are same. That is called as identical cells. And these two cells are connected to external circuit. That is, these two cells are in series. These two, in one case, these two cells are in series. In the other case, the same cells are in this fashion, parallel fashion. This, that is the series, is connected to external circuit like this, having resistance 4 ohm, again to the same resistance, that is 4 ohm. And they said current from this, either the cells are connected in series or parallel, current, net current flowing out is same current, like this, 0.5 ohm, it is given. So, given the data, that is external resistance value is given, and they said what type of the cells, identical cells, and I, what is that? Same amount of current, either they are connected in series or in parallel, same current is flowing to the circuit. If that is the case, what is the value? What are the EMF of the cells and internal resistances? First solution, right? What is meant by identical cells? This is the meaning of this. Then, in this circuit and this circuit, look at these two circuit. Calculate what is the value of phi. Calculate what is the value of phi. The same equation you can use. To calculate the value of phi, E divided by R by R. That is, since there are two cells, effective value. And for this, again I is equal to same equation. Effective values. So these are in series. So this is another known. So write what is effective series. That is, calculate what is EE, what is RE. Because for series is the equation, So E plus E, both are same, 2E. R plus R, 2R. So it is substitute that 2E, 2R, simplify E by 2 plus R. I equals E by 2 plus R, equation 1. Call this as equation 1. Similarly, calculate what is I for this one. This is parallel. For the parallel connections, write this what is effective E, what is effective R equations. These are E R. It is simplified 2ER divided by 2R. It is E only. 2R cancels E. What is E? Effective EMF of this connection is E. Similarly, calculate what is effective R. This is equation R by 2. Then put them into the equation. For this calculation, this is E divided by R by 2. Simplify. Take LCM and simplify. 2E divided by 8 plus R. I equals this for this. Equation 2. And the data says the value of phi remains same. This value of phi remains same. That means left hand sides are same. If the left hand sides are same, right hand sides must be equal. Let us equate the right hand side and see that what you get. This is right hand sides. E cancel. Then simplify, cross multiply, you get this value. R equals 4 ohm. That is, after equating that, you get the value of R. What is value of R? It is same as R1 equals R2 equals R equals 4. Internal resistance of both the cell, it is 4 ohm. Next is calculation of E. So for that, we can take this value and put into any one of the equations, the first equation or second equation. I have taken the first equation. So write what is I. I value is given 0.5 or 1 by 2. E value not known. R value already calculated. So if you cross multiply, simply you get this value. E equals 3. E equals 3 means E1 equals E2 equals E equals 3. 3 volt is internal resistance is the both the cells which is same. So that is the one they asked. Like this. So this is how the problem is solved. And the important step is, so whenever you read the problem, understand the problem and put the same problem in that, what is that, in diagram, it is in pictorial representation like this. Then only you can understand or solve the problem easily.